unmute me. Okay. Now everybody is getting my voice? Fine. So again, okay, I checked this with the book. It's saying, okay, fine. 40% of interviews of household with children during the evening. So when they are saying the 40% of the interviews, that means total households with children is having interviews is uh, DC. Okay, so it is again running. Okay, so here again I'm not able to write. So okay, leaving it that way. I will again write in the chat box. So fine. So constraint 5, it is a total number of households with children is DC plus EC, right? So if I want the 40% of this total interviews conducted in household, that will be 0.40 multiplied with DC plus EC. They are saying at least 40% of households will with children will be, so 40% or greater than 40% must be in evening. So here I'm getting this. I'm not able to right click here. Okay. I don't know why. It is going again. So here if you simplify taking everything on the left hand side, you will get 0.4 DC negative and negative 0.4 EC plus EC greater than equal to 0. So if you see and solve it, you will get negative 0.4 DC plus 0.6 EC greater than equal to 0. So same way you can get this sixth constraint also, and both are for evening. You can change if the constraint is such that this evening can be replaced with uh, day, then you can also change it. So I'm trying, I cannot write it. Now let's come back to the problem of this one, research problem, the solution of this problem. So I'm not right now able to give you the solution by Excel sheet, but I have already pasted it here, so you can see that here. So this is something from sensitivity analysis. So right now, don't look at the below things where we have a shadow price and we are not. So here just you can see the values. So we are getting the optimal values after solving it by solver, as DC is equals to 240, EC is equals to 160, and DNC 240, and ANC 360. So this is the values. For this value, what our objective function, if you plug in the value here in minimization of 20 DC line, the first line, which is the objective function, you can easily see that your objective function value is something, I am looking in the, or maybe we can, yes, solver will use the, there is a question by Sanjay, and I'm responding to it. Solver is using the simplest method to solve the problem and then give you the direct solutions. In the columns where the green line is there, green 4 columns there, it will just write the values there. So I'm also, so here we have these 4 values, and you can see the all constraints are satisfied here. So total daytime interviews are 480, which is greater than 40, and 520 evening interviews, that are also greater than. Similarly, here also all constraints satisfied, and the total sum of the all interviews are 1000. So here, if I plug in the values in my Excel, these values here, so I'm just writing it here. It's not solved 40 and 60. So you can see the cost is 20,320 now, and all constraints are satisfied. You can see here 2 constraints are satisfied with equality. So here you can see if RHS is equals to LHS, then this is a binding constraint. So here you can see these 2 are binding constraint, as well as these 2 are binding constraints. Here this is differ, RHS and LHS are differ. So these constraint 3 and constraint 4 are not the binding constraints. Where the slack values are 0, we say these constraints are binding constraints, that we have discussed in the previous class also. So right now, let me go back here and discuss the sensitivity, and later discuss the sensitivity of this problem also. So I'm coming to this. In the previous class, we have discussed the sensitivity of constraint, objective function, and constraint. So here you can constraint. So here again, if we are looking for this problem, this is an unbounded region problem and a minimization problem. So we got the minimum point here. At this point, here so just revising how we solve it, we just put the lines and then see which area is shaded, should be shaded, as it is greater than equal to or less than equal to constraints, depending on that. And then you get this yellow region as my feasible region. And then you see that this feasible region, we have this minimum point as well. So here, 3 extreme points, 1, 2, and 3, and this is unbounded on this side, so there is no extreme point. So 3 corner points or extreme points are here. So all on these 3 points, if we solve the 2 equation number, like this blue line and this red line, if I solve, I'll get this point. and this is constraint number 4x minus y and 5. So for this one, I'm getting this point, and then another point I'm getting by taking the intersection, and third extreme point is with y equals to 0, so 5 only, 5, 0 y. So all these three values, if I substitute the value in objective function of x and y, I'll get the values of z at these points, these three extreme points. So once you get these three values, you can choose the minimum. One way is to solve this. Another way, the same way in the Excel solver. Now I want to do the optimal objective function coefficients. If I change the objective function coefficients here, how much I change here, so my uh, decision objective function value will not change. That means I still be at this point, crossing the or touching this point in the constraint. How much I change the 5 and 2, these coefficient of objective function variables, how much I can change in these variables, which will not affect my optimal value of the problem. That I need to see. So here in the graphical solution, you can see that if you consider this is the part, if you rotate this line from here to this blue line, there is no change in objective function value. Similarly, if you rotate on this side up to this right line, there will be no change in objective function value. So this is the way how graphically you can look for the changes in objective function values, coefficients. So this is something, if we are saying this is cost related to x1 and this is also cost related to x1. So this x1, okay. Somebody is asking that, okay, Atul, where the dark line is coming from. Okay, dark line is the line 5x1 plus 2x2 equate to some constant c. First, initially we have taking it as constant c. Okay, so if I take it, suppose like this, okay, so x1 is 2, that means equal to 10. If I consider 5, bit louder, suddenly louder. Okay, I will try. So here, if I consider 5x1 plus 2x2, okay. So this line is something, if I consider it like this, then I just take a line and then considering this line and parallelly I'm taking this line up, 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 and find a point where it is just uh, touching the objective function, and then I get this line which is a objective function line. So, or we call it ISO cost line here because it's a minimization problem. So how much I change in this line, so my there is no change in the optimal value of the objective function. So it will remain 17.6. 17.6 is the solution of this problem. So 17.6 as I solved it here. So 16 by 5 x1 and x2 is 5 and x2 is equal to 4 by 5. This is our solution. For these two values, z value is 17.6, right? So this is our solution, optimal solution, minimum solution for this problem. And here I'm trying to give you uh, the sensitivity analysis by graphical, how we change the objective function coefficients. So I want to remain with this minimum value. I don't want to change it, but I should want to know that how much I decrease cost, or if the cost will increase from 5 to, for x1 raw material, suppose it's a raw material and you are trying to get, if it the cost of this x1 raw material will increase with from 5 to 6, what would happen? So we need to know that what levy we have with this coefficient, uh, so our objective function value will not change. So that way it is beneficial to see the sensitivity analysis of each variable coefficient in objective function, that what if we, if it is increased, then what happened? If it is decreased, what happened? So we have levy that we can rotate this black line from red line to this green line. We don't need to worry about the total cost. That will remain there only. So now rotating this will give us a flexibility. So if we rotate the equation, that means rotation means the slope will change, and that will change the coefficients here, nothing else. So by similarly, if okay, what happened when we change the RHS? So right hand side. Yeah, you are right. Yes, coefficients will change, then objective function will all, total value of objective function will change, but this point of decision, x value and x2 value will not change. Our proportion of purchasing the raw material, this one and this one will not change, or a product mix will not change. So without changing, yes, definitely, yeah, you are right. Uh, so it will affect the objective function value, but it will not change our solution point. So now when we are coming to RHS, so let's consider this for RHS 4x plus y greater than equal to 12. This RHS, this line, green line or blue line, if what happened if it becomes 13? So if it becomes 13, that means 4x minus y must be greater than equal to some 13. Then this solution space will shrink. I have already written over here. It will shrink and the optimal objective function value deteriorate. So how it will happen? So once you see that if I change this, this line will move this side. If this line will move this side, that means our solution space will become less. So this part less, suppose. This part is less, then this solution space, yellow space will shrink, and my value of of variables x1 and x and y will change, and as x and y will change, oh, so there is a change in, okay, so we are talking about earlier x and y, and then suddenly I come to x and, okay, y x2 is nothing, it's equivalent to y. So here you can see, uh, so this will change. So objective function value deteriorate. So if deterioration means it's a uh, minimization problem. So if the value, cost value increase from the previous value, that means the deterioration of the objective function value. Similarly, if I make it change this value from 12 to 10, then what happens? You can see, you can, if you draw the prob the line again, it will go little bit this side, on the this side. If it is going this side, that means your value will be enlarged and that will improve. So you are moving towards lower value, so that means it will improve your solution. So here we have to compute two things, so range of feasibility and shadow price for sensitivity analysis. So range of feasibility is the feasibility of the RHS values, how much we can change them, but still we are getting the same values, objective function values. And what is the shadow price? Shadow price is nothing but the rate of change of objective function by changing the right hand side of the values. How much change we are going to get in our objective function with respect to the change in the constraint RHS. That is shadow price. So we see it here also. Okay. So this is same problem. I'm not able to solve it, show you how it is solver will work and give you these answers. But let's say solver will work and then it is going to give you. So here you have, so again I'm repeating, initially you have to keep these two columns, light green columns 0 or no values there. So x and y are the variables and their coefficients in the just below that. Keep this green free. Then z is also you have to put equal to some product. So z is what? Actually, you can see from here 5x plus 2xy. So it's a product of whatever value here and the x value after optimal calculation, whatever you get there. So these two value, product of these two cells, and another sum plus product of these two cells. So this will, sum product will give you the taking a product of cell into this cell plus this cell into this cell. Okay. So fine. So constraints, just I have wrote it from here to here, and this. So sensitivity report, okay, reduced cost and everything you want to. So okay, in the next class we will more go on the sensitivity analysis, and um, we will play with the changes in objective function coefficients and RHS and how much they are going to affect on our optimality range and objective functions, binding constraints, all those things. So I just want to make one announcement that next Saturday I may not able to take class, so there is class will be cancelled on next Saturday, I will take class on Sunday. So 19th I will take class. For the cancellation of 18th class, I will take some extra class that I will announce later. I will put the notice on a website as well as uh, so there is no class on Saturday. We will meet on mm, Sunday at 2 again. By the time I resolve this problem with the Excel sheet, why it is not working. So thank you very much for today.